In this video, we're going to discuss a bit of memory, and we'll see why that's a pun later on. But first, I want to discuss a scenario where you're trying to communicate with someone else. For example, you might be a spy in the Cold War, and you're trying to communicate with another spy. And the only way you have of communicating is you want to put a light in your window. And you can use that light to communicate a message to your fellow spy. For example, maybe there's an assassination attempt planned for tonight, and you want to tell your friend whether or not you should go ahead with the assassination. So you put the light on in the window to say, yes, go ahead with the assassination. Or you turn the light off to say, no, don't go ahead with the assassination. So you can use this light in your window to communicate to your fellow spy two possible values. Go ahead, assassinate, or no, don't go ahead and assassinate. This system of communicating via light has actually been used throughout history in many different ways. So it's kind of interesting in that context. But the problem with this system is you can only communicate one message, yes or no, yes or no. What if you need to convey more information? Well, you might be inclined to hook your light bulb up to a dimmer, and then you could have a bright light indicate one message and the light be completely off to indicate another message. And you can use varying degrees of light in between to indicate different values. So on this system, for example, we can convey 5 possible messages. But the problem is we live in a real world, and it might be hard to tell whether that light is 3/4 on or half on or completely off, and it's a noisy signal. It's hard to determine for sure what the message will be. Instead, what we can do is put 2 lights in the window. With 2 lights, we can convey 4 possible messages. Both lights off, one light on, the other light on, or both lights on. So by varying the different light configurations, we can actually send 4 possible values. So with 2 lights and 2 configurations on each light, we can represent 4 possible values. If we manage to put 8 lights in our window, then there'll actually be 256 possible values. That is quite a large number of values. You could actually send a very detailed and complex message to your fellow spy. Maybe you have a code book that explains what each number means, and you can actually give quite a detailed information with just 8 different light bulbs. But if we were to add 20 light bulbs, you could give over 1 million possible messages or values. And that is a large number of values. Now, I know what you're thinking. Light bulbs can burn out. You're going to need a lot of extension cords. We're not talking about the practicalities of this example. What we're doing is giving an example of how you can convey information with simple light bulbs. You may be familiar that computers use internal switches or transistors, or as we can think of them as little tiny light bulbs inside of a computer. And basically each one of those switches is off, meaning 0, or on, meaning 1. And each individual switch inside the computer can be switched on or off to convey a message of 0, 1. The reason only 2 possible values are used is the exact same reason that our spies didn't use a dimmer switch on a light bulb. They used multiple light bulbs. And that is because it's very easy to detect using circuitry whether a light is on or off. But determine whether a light is half on or half off is actually quite difficult. So that is the reason why they use switches inside of computers. Now, this representation for 0 to be off and 1 to be on is actually pervasive through our society, and we've adopted it in many ways. You may not have ever noticed it before, but now you will see it all over the place. For example, a switch often uses 1 and 0 to indicate whether or not it is on or off. And when you use the same button to turn a device on or off, they actually use a logo that shows a 1 and a 0 together. You've probably seen that logo many times and not clued in that it's a 1 and a 0. So as I said, computers actually have billions of switches or transistors inside of them. And those switches are used for 2 purposes. The first is logic, and the second is memory. So in this diagram, we can see how a simple switch can be used to represent our different logical operations. Now, we've already had a discussion about Boolean logic, but this just shows you a quick example of how switches could be used for our different logical operators. For example, with an OR switch, if any of the switches are flipped, the light will turn on. For an AND switch, both switches have to be turned on for the light circuit to be connected. And similarly, we can set up a NOT switch to be the opposite of what we want. This is an oversimplification, but all the little logic that exists in a chip are performed using switches like this. The other way that switches are used is to store memory. And each 1 or 0 can be stored in memory, and it is known as a bit. Now, bit stands for binary digit, and we combine 8 bits into a byte. That is a fairly arbitrary grouping. Some white dude decided a few decades ago that 8 is a good number, so we grouped 8 bits into a byte. It was a bit of a pun because of bits and bytes, and to distinguish it from a byte, as in taking a bite of an apple, they spelled it with a Y. So that is why we have the term byte, and all it really means is that there's 8 bits. So whenever you think about a byte, you should think about 8 light switches together, and those 8 light switches together can be also represented with ones and zeros. Earlier, we talked about bytes in your computer memory and RAM and in storage, but now we have a better appreciation of what a byte actually is. It's 8 little tiny light switches. And that's why we started off this section by talking about a bit of memory, because memory is stored in bits.